Mr. E here. Our aim for the video is how do we determine the domain and range of a function from its equation. Okay, so recall that the domain is the set of all first elements of ordered pairs. So the domain, that's your x coordinates. You can also think of the domain as the inputs. The range is the set of all second elements of ordered pairs, and your range, that's your y coordinates. You can also think of the range as your outputs. Okay, so as a warm-up, I want you to look at the graph of the function below, and I want you to answer the following. Is it possible to ever have a y value of -1? Why or why not? So from looking at the graph, you can see that it's not possible because according to the graph, all the values of y are 2 or greater. Since the function will only output y values of 2 or greater, it is said that the range is 2 or greater. So we've already talked about what range and domain is in the past, so I'm not really going to go into detail about that. What I do want to go into detail about is the different ways to notate the range. So remember, so looking at this graph here, we can see that the range is 2 or greater. So one way we can write that is by writing that 2 must be less than or equal to y, which is the same as saying y must be greater than or equal to 2. Another way to write that is to write it this way, and you should be familiar with all these different ways of writing it. Now this one you might not be familiar with, so let's talk a little bit about what this bracket and this parentheses means. So let's talk about the brackets first. As an example, I have open bracket a comma b close bracket. The bracket symbol defines a set of numbers that include a and b. So in this set, a and b is included, as well as everything in between a and b. So for example, let's say you have 3 comma 7 inside these brackets. That includes 3, 4, 5, 6, 7. So 3 and 7 is included. In contrast to that, we have the parentheses. So as an example, I have a and b inside the parentheses here. The parentheses symbol defines a set of numbers that do not include a and b. So for a and b here, everything in between a and b is included, but a and b is not included. Or think about it this way. We have 3 and 7 inside this parentheses. That only includes 3 numbers, the numbers in between 3 and 7, but not 3 and 7. So 3 and 7 in parentheses only includes 4, 5, and 6. So going back to our initial graph, we can write the range like this. You can say that the range includes 2 all the way up to infinity. Let's think about what is the domain of the function above. If you recall, your domain is your x values. So x can be any real number according to this graph. Another way to say that is that x can be any number in between negative infinity to positive infinity. So one way we can write that is like this. X can be any real number. Or we can write it this way, from negative infinity to positive infinity. So let's write it that way. So let's say the domain is from negative infinity to infinity, which is another way of saying x can be any real number. Alright, so as our first example here, we're being asked, what is the domain and range of f of x equals radical x minus 5? So we have a radical function here, and that's important to note. This is a radical function because we have a radical sign. In this radical function, it's important that you know the following. If x minus 5 produces a negative number, f of x will be non-real. In other words, if we have a negative under the radical, f of x is non-real. In general, for radical functions, the domain is limited to the values of x that make the radicand greater than or equal to 0. And so, in other words, we want to know what are the values of x that give real solutions, and that's our domain. So to do that, just think about it like this. When is x minus 5 greater than or equal to 0? So we can write an inequality and solve for x, and that's going to give us our domain. Plus 5x has to be greater than or equal to 5. That's our domain. Okay, let's think about why. Think about why the domain has to be all the values of x greater than or equal to 5. What would happen if you insert 4 in here? So 4 is less than 5. You would have 4 minus 5, that would be negative 1, and then you'd have radical negative 1, and that's a non-real solution. And we cannot have that. Okay, so that's how you get the domain in a radical function. You solve for the values of x when the radicand is, you solve for the values of x that will make the radicand greater than or equal to 0. To get the domain, excuse me, not to get the domain, we already got the domain. To get the range, you're going to take, so let me just erase this before it gets too cluttered. So to get the range, you're going to take that 5, that smallest possible value of x, and you're going to insert it in here. And the range, so if we take that 5, substitute it in there, that's 5 minus 5, that's 0, the square root of 0 is 0, so then the range is all the values greater than or equal to 0. So you get the range by substituting the smallest possible value of x. Because remember, the range depends on the domain. So that's why we have to substitute the domain in there. If you want to see a visual of this function, here's a visual. Notice that it agrees with the domain. See that? That's 5 right there. So the domain is x greater than or equal to 5. So that's why in the graph you only see x values for 5 or greater. It agrees with the range as well. From 0 all the way to infinity. Okay, so here we have an example. I want you to try it. See if you can find the domain and the range of this function. So to get the domain, you're going to set the radicand greater than or equal to 0, and you're going to get x is greater than or equal to negative 2. So that's the domain. To get the range, you're just going to take that negative 2 and substitute it in for x, and then just solve for f of x. So that's 3 times negative 2, negative 6. Negative 6 plus 6 is 0. Radical 0 is 0. 0 times 2 is 0. So y is greater than or equal to 0. So your range is, wow, that that squiggly did not come out the way it's supposed to come out. Let's try that again. There it is, a little better. Okay, let's try another type of function. Here we have a rational function and we're asked to find the domain. So this time it's important to note that if the denominator of a rational is 0, it is undefined. So this is a rational function, and we know that we cannot have 0 in the denominator. So we're going to take that denominator and we're going to set it equal to 0, and we're going to solve for x so we can know what x cannot be. So we solve for x, we got x plus 3, x minus 3, that's the factorization of x squared minus 9, and we get x equals plus or minus 3. In other words, x cannot be, we cannot use plus or minus 3 over here. Why not? Well, because if you use plus or minus 3, you're going to have 0 in the denominator. Try 3 for it. 3 squared is 9. 9 minus 9 is 0. So then you're going to have 3, you're going to have 0 in the denominator, which you cannot have. So x cannot be plus or minus 3. So what's the domain? The domain is all real numbers, but x cannot be plus or minus 3 because that would mean you have a 0 in the denominator, which you cannot have in a rational function because that makes it undefined. If you want to see a visual of this, we can certainly put this in our graphing calculator. 3x squared over x squared minus 9. And you're going to notice that you have asymptotes at -3 and 3. The reason you have those asymptotes is because the function is undefined at 3 and -3. It's not a continuous function. Okay, so now you try it. Find the domain of this function. So since this is a rational function, we're interested in when is the denominator equal to 0. So if we solve for x here, we're going to get x plus 5, x plus 1 equals 0, x equals -5, x equals -1. So that means that for the domain, x can be any real number but it cannot be -5 and it cannot be -1. So it could be any real number except these two numbers, because these two numbers will produce 0 in the denominator, which we cannot have. That's supposed to be a 0. Okay, I hope this video helps. Take care.